In this video, we're learning about the law of cosines. And if you guys haven't already done so, I encourage you to watch our video on the law of sines because we will be using the law of sines throughout this video. So if you haven't already learned that, go ahead and check out the link in our description and you can watch that video first. So if you already know the law of sines, then let's jump into the law of cosines. So at the top of the screen, you're going to see these three formulas and they look pretty similar. The variables are just in different positions and they pretty much are the same formula. They're just referencing different sides and angles in a triangle. And those are going to make more sense once we actually do some examples. So I'm not going to talk about those until we jump into example 1. But what I do want to mention is that just like the law of sines can be used for any type of triangle, so it doesn't have to be just for right triangles, the law of cosines can also be used for any type of triangle, not just for right triangles. So let's jump into example 1, which says solve the triangle below. And remember, when it says solve the triangle, we're just solving for all of the missing sides and angles. So they gave us two sides and an angle, and you guys may be thinking, why don't we just use the law of sines? And the reason we can't use the law of sines is because we don't have any angle side pair. So we have angle B, but we don't have side B. And let me just label side B. And then we have side C, but we don't have angle C. And we have side A, but we don't have angle A. So when this happens, we have to use the law of cosines. So I'm going to show you guys how we can do that. So we are given angle B, side C, and side A. And what we're going to do first is solve for side B. So the formula from up top that we want to use is this middle one right here, because this middle one is going to help us solve for side B. The other two will help us solve for side A or side C or angle C or angle A. This middle one's going to help us either solve for side B or angle B. So we're going to use that one. So I'm going to go ahead and just write that formula down here. So we have b squared is equal to a squared plus c squared minus 2ac cosine b. And now we're just going to plug in what we know. So we don't know b, so we're going to leave that as b squared. We know that a is 10, so we're going to have 10 squared, plus c is 8, so 8 squared, minus 2 times our a value of 10 times our c value of 8 times the cosine of angle B, so the cosine of 60 degrees. And now we just want to simplify the right side. So we're going to have b squared, 10 squared is 100, 8 squared is 64, and then minus 2 times 10 is 20, and that times 8 is going to be 160, so minus 160 times the cosine of 60 degrees. And now I'm just going to put this entire right side into my calculator, and then we will take the square root of both sides to solve for b. So if you put the right side in your calculator, you should get b squared is equal to 84. And then remember, to solve for a variable when it's being squared, you're going to take the square root of both sides. So we're going to square root the left side, square root the right side. On the left side, square rooting a squared just cancels each other out, so we're left with b. And on the right side, we get the square root of 84. And I'm just going to put this in my calculator to get a decimal approximation. And the square root of 84 is roughly 9.17. So we get that side B is, so let me write that again. Side B is roughly 9.17. And now what we're going to do is we still need to solve for angle A and angle C, and this is where the law of sines is going to come in handy. You could use the law of cosines again, but the law of cosines is harder than the law of sines, so I think it's easiest if we use the law of sines to solve for angle A or C, and then we'll solve for the third angle by using the fact that the sum of the angles in any triangle is 180 degrees. So let's just solve for angle A. So what we're going to do is use the law of sines. So remember, the law of sines says the sine of any angle in a triangle over that side that corresponds to it is proportional. So we could say the sine of B over side B is equal to the sine of angle A over side A. And now we are going to plug in what we know. So we know angle B is 60 degrees, so we're going to say the sine of 60 degrees over side B, which we just found is 9.17, is equal to the sine of angle A, and we're solving for angle A, and over side A, which is 10 inches. And now what we're going to do is we want to get the sine A by itself. So we're going to multiply both sides of our equation by 10. On the left side, we're going to have 10 times the sine of 60 degrees over 9.17. And on the right, the 10s cancel out and go to 1, so we're left with sine A. And then remember to solve for an angle. If we have the sine of that angle, we need to sine inverse both sides. So on the left side, we're going to have the sine inverse of this entire expression. And on the right side, sine and sine inverse cancel each other out, and we are just left with angle A, which is what we're looking for. And now I'm going to go ahead and just put this left side into my calculator. And if you do that, you should get that angle A is roughly 70.81 degrees. So let's just box what we've gotten so far. So we got side B. We know angle A is roughly 70.81 degrees. And now we can easily find angle C. So let's just write 70.81 degrees. And now we have to remember that the sum of the angles in any triangle is 180. So we can say angle C plus angle A, which is 70.81 degrees, plus angle B, which is 60 degrees, is equal to 180. And we can subtract 70.81 and 60 from both sides of our equation. And if we do that, we should get that angle C is equal to 49.19 degrees. So we've solved for all the missing angles and sides in this triangle, so we know we're done with this problem. And now we're going to go over one more example where we are solving for an angle instead of solving for a side first. So for example 2, they don't draw us a triangle, they just give us information about triangle ABC. They told us side A is 9 feet, side B is 5 feet, and side C is 7 feet. So this time we just have all three sides and we don't have any angles. So I'm just going to sketch a triangle. It's not fully going to be drawn to scale. So side B is 5 feet, side A is 9 feet, and side C is 7 feet. And we'll fill in angle C, angle B, and angle A. And because we don't have an angle side pair, we can't use law of sines, so that's why we have to use law of cosines. It doesn't matter which of these top three formulas we use because we can solve for any of the three angles. So let's just go ahead and solve for angle A. So if we're solving for angle A, we're going to want to use this first equation because it has angle A in it and side A, and the other equations don't have angle A in it, so we have to use the first one. So I'm going to go ahead and rewrite the equation. I know A squared is equal to B squared plus C squared minus 2BC times the cosine of A. Now I'm going to plug in what I know. So I know A is 9, so I'm going to have 9 squared is equal to B squared, so 5 squared, plus C squared, so 7 squared, minus 2 times my B value of 5 times my C value of 7 times the cosine of A. And now I just want to simplify a little bit. So 9 squared gives me 81 on the left, 5 squared is 25, 7 squared is 49, minus 2 times 5 is 10, times 7 is 70. So minus 70 times the cosine of A. And now let's just simplify the right side a little bit more. So we're going to put together the 25 and the 49 to get 74 minus 70 times the cosine of A. And now what's really important is that you cannot subtract 74 minus 70. A lot of students want to do that because the 70 is being multiplied by cosine of A. So order of operations tells us we can't do that subtraction first, and we can't actually multiply the 70 by cosine of A right now because we don't know what A is. So what we're going to do is we want to subtract 74 from both sides. So we're going to take away 74 from both sides of our equation. On the left side, 81 minus 74 is going to give us 7. And on the right side, we have negative 70 times the cosine of A. And now what we're going to do is divide both sides of our equation by negative 70. And so on the left side, we're going to have negative 7 over 70. And on the right side, we're going to have cosine of A. And you can simplify the left side if you want, but it doesn't actually matter because we're just going to put it into our calculator. So now what we want to do is solve for angle A. So to get rid of that cosine, we have to cosine inverse both sides. So we're going to take the cosine inverse of the left side, so negative 7 over 70. And when we cosine inverse a cosine, they cancel out, so we're just left with angle A on the right, which is what we want. And now we're going to put the left side into our calculator. And if you do that, you should get that angle A is roughly 95.74 degrees. So now we know what one of our angles is. So now what we can do is use the law of sines to find one of the other angles. So let's go ahead and just solve for angle B. So we are going to say that the sine of angle A over side A is equal to the sine of angle B over side B. And we're going to plug in what we know. So we're going to take the sine of angle A, and angle A is 95.74 over side A, which is 9, is equal to the sine of angle B over side B, which is 5. We're going to multiply both sides of our equation by 5. On the left, we're going to have 5 times the sine of 95.74 over 9 is equal to the sine of angle B. And then to solve for B, we have to sine inverse both sides. So on the left, we're going to have the sine inverse of this entire expression, 5 sine of 95.74 over 9. On the left, on the right, the sine and the sine inverse cancel out, so we're going to just be left with angle B, which is what we want. And now we're going to put this entire thing into our calculator. And if we do that, we should get that angle B is roughly 33.56 degrees. And now all that's left to do is solve for angle C. So remember, the sum of the angles in any triangle is 180. So to find angle C, we can take 180 degrees and just subtract angles A and B. So we can subtract 95.74 degrees and subtract 33.56 degrees. And we're just going to go ahead and put that in our calculator. And we're going to get that C is about 50.7 degrees. So we found all 3 missing angles, so we are done solving our problem. So hopefully this video helped you guys understand the law of cosines a little bit better. If you want some more practice with problems like this, check out the link in our description for a free practice worksheet.